Hello everyone, welcome back to the online class 10. So we are continuing the same topic, electric current and circuit, and in the previous video we learned about electric current. So electric current is basically the flow of electric charge through any conductor in some time, during some time period. So from there we got the formula I equal to Q by T, where I was the electric current, Q is the charge flowing through the conductor, and T is the time taken by the charge to flow through the conductor. Then from there we got 1 ampere equal to 1 coulomb by 1 second. This means that 1 ampere of charge is, or 1 ampere of current is 1 coulomb of charge flowing through any conductor in 1 second. That was known as 1 ampere of current or 1 ampere. So this was the previous topic. Now we'll continue in the same part, and today we'll discuss about circuit. Now what is a circuit? Circuit is a closed path or is a closed loop, or you can say simply like a path through which electric current flows. So like in your home, there are inside a room in your home there can be a fan, a tube light and a bulb comprising of other electrical appliances which are all connected to a single board. So if you want to turn the fan on, you turn the switch on of the fan and the fan starts to move. You want to turn the bulb on and off, on or off, you can turn the switch on or off respectively, the bulb will glow or turn off. So these all components, the connection between all these components is known as the circuit. Now simply by directly drawing a circuit exactly how it looks is difficult. For example, if someone asks me to draw the structure of a fan and a bulb inside a room, so if my drawing is not so good, it will be difficult for me to draw it. So in this case, we use some pictorial representations to make the other people understand easily and make the diagram of the circuit easy to understand and easy to explain. So this where we use circuit diagram, or basically we are talking about the circuit. So normally if you are drawing a circuit, we will take up our source. Here I am taking a battery. I will explain how these things has to be made. This is a battery. These are wires. With the wire, there should be a switch. There is a switch, and the wire continues connecting the battery to a bulb, and forward the bulb is connected to a resistance. We'll talk about it, what is the resistance, what is the battery, how it is drawn, I will explain to you. And finally it is connected to another component known as emitter, and this is how a circuit is made. This is the simple representation, or you can say a simple schematic representation of a circuit. This is the battery, power source. This is the key. This is the battery. This is our bulb. This is the resistance, simply known as R, and this is the ammeter. So all these things connected together in a proper way is known as a circuit. Now we'll see how or which symbols has to be used or has to be taken. I'm just rubbing this one. Now before drawing a circuit, we should know how these symbols look, means which symbol has to be used where. First of all, the main component of any circuit, that is the battery or the power source. If means to draw battery in a diagram, we use two lines like this. We use two lines like this. One line is short, one line is long. The longer one is the positive side and the shorter one is the negative side, which are connected via two terminals. Remember, every electrical component, any electrical component always have two terminals. One is for the positive, one is for the negative. That is why here also we are drawing two terminals, positive and negative. This is known as a cell. This is a cell. Next, if two cells are to be connected, that means this is one positive side of one cell, negative, which is connected to positive and negative. This kind of combination, connecting two or more cells together, is known as a battery. Battery. Positive, negative, positive, negative. So finally this side negative and this side will be the positive. This is the battery. Next is the switch. This two brackets connected with two terminals is the switch. When this inside the switch there is no symbol, nothing, then this is off, and inside, and if it is like this, then this is on. Off, and within these two brackets if there is a dot, that is on. Next are the wires, connecting wires. Wires are simply shown by lines. The lines represent wire. And if there is a connection, means if two wires are connected together, then it is shown like this. Means here in the diagram you can see one wire from the top, one wire below. These are connected here with the dot. This is a connection. And if two wires are not connecting, they are just overlapping over each other, one going over another, then first wire and second wire have to go like this, and a jump or a curve and going like this. This is a wire overlapping, one wire going over another one. Next is the bulb. Bulb is shown like this. If it is like this, this bulb is off, and if the bulb is like this, having some ray-like structure on top, that means this bulb is on, off. Then comes our resistance. Resistance is actually a component which is used in any circuit, and the work of the function of the resistance is to reduce or to limit the flow of current. For example, if I have a bulb 4 watt or 4 volt for example, connected to a battery of 6 volt. So what will happen? From the battery 6 volts of current will come and will destroy the bulb, because the bulb's capacity is of 4 volt. Now if I connect a resistance there, that resistance will lower the current, and the capacity and the total amount of current coming through the battery will be reduced, and the bulb will glow easily without getting damaged. So resistance is shown by zigzag lines like this. This is a fixed resistance, means this resistance has a fixed value. This value cannot change. Secondly, if the resistance is like this, having an arrow within it, this is a variable resistance. Or if zigzag lines and from there an arrow like this, this is also, these two are variable resistance. Variable resistance are most commonly used in fan regulators. You have seen in a fan regulator, if you turn the knob in the different positions like 1, 2, 3, 4, what happens? The speed of the fan can be increased or decreased. So that is the function of a variable resistance. That knob, inside the knob there are some components which help to increase the flow of current and decrease the flow of current to the fan, so that the speed of the fan can increase or decrease. Then comes our most important two components, which are very new terms to you, given by symbols. One is like this, V, two terminals, plus and negative, positive and negative, and another one having a circle with a symbol A. These are two specific components used in a circuit. The first one, having V in the center, is known as voltmeter. This is known as voltmeter. The function of voltmeter is to check the voltage or to know about how much voltage is flowing through any of the component in a circuit. So it gives voltage. The second one is A. It's a circle with a symbol word written A. This is ammeter. The function of ammeter is to know or to inform about how much current is flowing through the circuit. So ammeter helps us to know about, gives current, means it helps to know about current. Ammeter helps us to know about the current. So the work of voltmeter is to know about voltage, and the work of ammeter is to know about the current in any circuit. These all diagrams you will get in page number 203 in your NCERT book, and this all you have to use whenever you are drawing the circuit of any component. Whenever you are drawing a circuit diagram, you have to use these components. So I am just rubbing this. Now, how to use these all? First of all, the connection always starts from a battery. That means we have to connect the battery. This is our battery, our source. The longer terminal, longer end is the positive, the shorter one is the negative. Then, from the battery, we have to connect a switch. Now it does not matter when you connect. If you are connecting the switch to positive, that is also okay. If you are connecting the switch to the negative, that is also okay. So for my convenience, I am just taking the switch here. That is the key or switch. Wire extended, and the wire will go to the components. This is wire. Next is our bulb. For example, if I am connecting a fan or a bulb to the circuit, that one we will use. So here we can draw a bulb like this. This is the bulb. Next is our resistance. So resistance, the function of resistance or the work of resistance is to limit or reduce the flow of electricity or electric current in a circuit. So I can just place the resistance here, so that means it can be placed here, it does not matter. Then comes, now from the battery current is flowing like this. This is positive terminal, no? So current will flow like this when the switch is on. So this is how the current will flow. This is the direction of current, and this is the resistance. Now after the resistance, I want to know how much current is there in the circuit. So here I will connect an ammeter. See here, the circuit is starting from here, going like this, and I am connecting the ammeter here. That means after the current has gone through all the components, then I want to know how much current is there. So it will be connected here. This is the positive terminal, like this it will go. So this will be the positive side, like this. Then it will come back to the circuit like this, and this will be our negative terminal of the emitter. Negative connected to negative, positive connected to the positive via the components. Now I want to know how much voltage is used by the bulb. So voltmeter has to be connected like this through this connection. Taking connection from this wire, I will connect voltmeter here. This is V, and this is the positive side. Positive connected to positive, negative to here. This is how the components of the circuit has to be connected. Remember, the voltmeter is always connected to the parallel side or with parallel to the component, and emitter is always connected as series. This much only for today. Thank you.